Good morning, all of you. Yesterday we have talked about resistances. So let us today talk about combination of resistances. So in practical electrical circuits which are used in our homes and everywhere, we generally need controlled current and voltage. Different components in an electrical appliance require different voltages and currents. And to obtain this, certain combination of resistances are used. So the resistance can be combined in two ways. One in series and other is in parallel. So today we are going to discuss series combination of resistance. When two or more resistance are joined end to end like this, end to end. This is the symbol for resistance. So when two or more resistance are connected end to end so that the same current flows. So in series circuit, same current flows. Same current flows throughout the circuit. So same current flows through each of them. They are said to be connected in series. Again, when two or more resistance are connected end to end so that same current flows through each of them, they are said to be connected in series. And according to the law of combination of resistance in series, the combined resistance of any number of resistance connected in series is equal to the sum of the individual resistance, like this. R is equal to, where R is the equivalent resistance, which will be equal to the sum of the individual resistances. So when a number of resistances are connected in series, their equivalent resistance is equal to the sum of the individual resistance. For example, if I take two resistance of, let us say, 3 ohm and 5 ohm, okay, and if I ask you what will be the equivalent resistance for these two resistances, so the equivalent resistance comes out to be 3 plus 5 equal to 8 ohm. Okay, I hope this is clear to you all. Now let us see the derivation of the law of combination of resistances in series. So this is the derivation for the combination of resistances in series. So let R1, R2 and R3 be the resistances connected in series. Let I be the current flowing through the circuit, and let V1, V2 and V1, V2 and V3 be the potential difference across R1, R2 and R3 respectively. Let potential difference across the battery be V, then potential difference of the circuit will be given by V is equal to V1 plus V2 plus V3. Now according to Ohm's law, we know that V is equal to IR. Now we have to apply this Ohm's law to the individual resistance separately. Okay. Now applying Ohm's law to the three resistance separately, we get this equation. V1 is equal to I into R1. Here I is the constant. When we applied to V2 across a resistor R2, we get potential difference is equal to I into R2, and V3 will be equal to I into R3. Now we have to put these three values in equation 1. So instead of V, we can write IR from Ohm's law, and V1 can be replaced by IR1, V2 can be replaced by IR2, and V3 can be replaced by IR3. Okay, I is common from here. Here I is common, so I will be cancelled out. I is common, I will be cancelled out from here, and we will be left with this equation. R is equal to R1 plus R2 plus R3. So from here it is clear that equivalent resistance of the resistances combined in series is equal to the sum of all the resistances combined in series. Therefore, we concluded that some that the sum total resistance in series resistance connection is equal to the sum of the all individual resistances, and this equivalent resistance is higher than the each individual resistance. Whatever will be the value of R will always be equal to the sum of these individual resistances. So I hope this derivation is clear to you all. Now let us conclude what we have studied about series combination of resistance. So when two or more resistance are connected in series, the total resistance of the combination is equal to the sum of all the individual resistances, like R will be equal to R1 plus R2 plus so on. And when two or more resistances are connected in series, the same current flows through each resistor, because current remains the same in the series circuit, and each resistance will have different potential difference. So this is all for series combination of resistance. Tomorrow we will talk about parallel combination of resistance. Thank you.